Welcome to the lesson on Modbus state flow and error codes. In this session, we'll look at how a Modbus slave processes requests, transitions between states, and handles exceptions. This will conclude our Modbus primer and prepare us for the practical lessons ahead. Today, we'll examine the Modbus slave state flow, look at common Modbus exception codes, and practical examples of exception responses. By the end, you'll clearly understand Modbus error handling. Let's start with the state flow. Okay, so let's walk through the Modbus slave state flow step by step. First, the slave starts in the idle state, waiting passively for a request from the master. No processing occurs here, it's simply waiting. When the slave receives a request from the master, it moves to the checking request state, where it validates the request. If the frame is invalid, or the request isn't addressed to this slave, it immediately returns to the idle state without responding. If there's an error in the request data, such as an invalid function code, address, or value, the slave transitions to the formatting error reply state to prepare an exception response. If the request passes validation successfully, the slave proceeds to the processing required action state where it performs the requested operation, such as reading from or writing to registers, and additional validations may occur. After successfully processing the request, the slave moves to formatting normal reply to prepare and send a response containing the requested data or an acknowledgement. In the case of errors during request validation or action processing, the slave enters the formatting error reply state, generating an exception response indicating the error encountered. And lastly, after sending either a normal or error reply, the slave returns to the idle state, ready for the next request. We'll see this flow in action when integrating Modbus middleware into our application later on. Okay, now let's review the commonly used Modbus exception codes. The first is a legal function, code 1. This occurs when the master sends a function code that the slave does not support. Next is a legal data address, code 2, triggered when the master requests an address outside the valid range. A legal data value, code 3, occurs when the master sends an invalid or out-of-range value. Slave device failure, code 4, indicates an unrecoverable error within the slave device, such as hardware failure. There are additional optional codes you might encounter, such as acknowledge, code 5, used when the slave needs more time to process the request, and server busy, code 6, indicates the slave cannot currently handle new requests. And then there's also memory parity error, code 8, used for internal memory parity errors. Okay, now let's take a closer look at the exception response format. An exception response starts with the slave address, clearly identifying the responding device. The next field is the function code plus hex 80, indicating an exception response. Then comes the exception code itself, specifying the exact error encountered. Finally, the CRC ensures integrity during transmission. And here we have two examples. For legal function code 1, if the master sends an unsupported function code hex 10, the slave replies with hex 90, indicating an exception. For a legal data address, code 2, if the master tries accessing an invalid register using function code 3, the slave replies with hex 83. Before we wrap up, let's review two additional exception response examples. For a legal data value, code 3, if the master sends an invalid value for a register, the slave responds by adding hex 80 to the function code and returns exception code 3. In the case of slave device failure, code 4, even if the master request is valid, if the slave experiences an internal error during processing, it responds with the function code plus hex 80 and exception code 4. So by following this exception response format, you can easily identify the type of exception. And that's a wrap for our Modbus primer. Next, we'll move into a practical demonstration to preview the Modbus implementation in action. See you in the next lesson.